Hi, this is Dr. B. We're going to do the Lewis structure for CH4 methane. Cows make a lot of methane. And we'll first take a look at the periodic table. Carbon is in group 4 or 14, so it has 4 valence electrons. Hydrogen, group 1, it has 1 valence electrons. So we have 4 for the carbon plus 1, but we have 4 hydrogens. So let's multiply that by 4 right there. So 4 plus 1 times 4. 8 valence electrons for us to work with here. We'll take and put carbon right here. Hydrogen always goes on the outside, and we have 4 of them. Put those on the outside, and now we have 8 valence electrons to work with. So let's take those and form bonds between the carbon and the hydrogen. Put a pair of electrons there. We have 8 valence electrons, so 2, 4, 6, 8. So we formed those chemical bonds, hydrogen and carbon, and we used the valence electrons up. Let's see. We used 8 around the carbon, so that's good. Hydrogen only need 2 for a full outer shell. That hydrogen's good. Yep. So we've done it. That's the Lewis structure for CH4 methane. We could write it as a structural formula, and that would look like this right here, where the single lines represent a pair of bonding electrons. This is Dr. B, and thanks for watching. Hi, this is Dr. B. Let's look at CH4 methane. We'll start with the molecular geometry. The first thing we need is a good Lewis structure. Once we have that, we can figure out the molecular geometry for CH4. To do so, we'll use this generalizable format. So here, A is the main atom, the one we're interested in, and that's carbon. We have one of those. X are the atoms bonded to the atom of interest, the carbon. So we have 1, 2, 3, 4, where these lines, they represent the chemical bond. So we'll put a 4 right here. And N represents the non-bonding electron pairs. Well, all the electron pairs are used up, so we don't have any non-bonding. We can just get rid of that. And that leaves us with AX4. Once we have this AX4, we can then look on a table to find the molecular geometry. So we go down AX2, AX3, there's AX4, and it's tetrahedral. So the molecular geometry of CH4 is going to be tetrahedral. And that's going to look like this right here. The carbon is in the center, and then the hydrogens are on the outside. We can see the bond angle is 109.5. That's going to be this angle right here. And the hybridization will be sp3. When we look at CH4 rotating, you can see that there really is no difference between the sides. They're all the same. Because of that, it's going to be a nonpolar molecule. So there you have it. You can find the molecular geometry, bond angle, hybridization, and polarity for CH4. This is Dr. B, and thanks for watching.